I want to go over a few ways of calculating power. Now, the key idea about power is it's the rate at which work is done. So the first way of calculating power is P. P is the letter we use for power. I know it's also pressure. It's a little confusing, but always keep in mind context. You can always figure out what something is from the context. So power is work divided by time. So if you know how much work is done in a certain amount of time, then you can take that work and divide it by the time. Sometimes you'll have to figure it out from the change in the potential energy or the change in energy of the system. So delta U over T. Okay, so the change in the energy of a system. Let's take a minute to think about the units here. So if power is work divided by time, and the units, work is in joules, right? And time is in seconds. Time is seconds. Now, what is a joule? A joule is a kilogram meter squared per second squared. And this is per second. So the fundamental units of power are kilograms, meters squared per seconds cubed. And this is the definition of a watt. So the unit for power is the watt. We abbreviate it capital W, which is confusing because that's also the letter for work. But that's what we use. Now, check this out. A kilogram meter squared per second cubed. We can also break this down as kilogram meter per second squared times meter per second. Now that's interesting because the units here, these are the units for force times velocity. And that actually gives us a separate equation now for power. Power, one way of finding instantaneous power is force times velocity. If you're in an advanced class, this is actually a dot product, F dot V, which is, FV cosine theta. Right? Because realize force and velocity are both vectors, and power is a scalar quantity. So if we take two vectors, we have to figure, well, how are we multiplying them, right? So it's a dot product between the two of them. Okay. And then if you're in an advanced class where you've actually got calculus going on, another way of calculating power is dW dt. You may have a function for the work, and that would, if you take the derivative of that with respect to time, then that would actually give you the power function. So those are three ways of calculating power. And like I said, if you're in an advanced class, then you've really got to be familiar with all three to be able to use any of those at any particular time.